maybe just to start, I would give to the audience a little bit of an intro about who we are, who Frogix is, who you are, and I hope you're gonna take this also part a little bit in more detail and take us a little bit more detail through what you're doing, where you come from, and what's your journey to sustainability or with sustainability, why we talk today here on this topic. So that is quite an interesting part. And then I would suggest we deep dive on what we are here to talk about, which is distributed power generation and all the topics around why emissions are important, what emissions are important in the value chain, what are the impacts for businesses, and what they can do about that, how Capstone can help with your solutions that you're offering, what is new about this, what is innovative and efficient about the solutions that you provide. And then I would just chip in a little part about microgrids, because distributed power generation is apparently super related to the topic. So let's
absolutely
talk a little bit more about that, if that is okay for you.
Yes, absolutely.
Super. So when we talk about a distributed power generation, and maybe I'm just gonna quickly go back to what Frogix is about, just also for the people in the call that they know a little bit more about us. So we are a green tech marketplace supporting businesses offering sustainable and ecological solutions in sustainable building, sustainable construction, and sustainable living. And also that's the big link why we have today John Babcock with us from Capstone this topic. Now, John, you are a representative from Capstone Energy. What brought you to the sustainability topic itself, and what's your motivation in this?
We are the lowest scope 1 emissions distributed power generation microgrid equipment supplier. So that's how we came. Mm-hmm. That's how we started life. So we were way ahead of the curve as a technology. We were funded originally by Bill Gates, who saw the potential in terms of the challenges, the challenges of energy security, mm-hmm. and climate change and air quality. And so he was an early investor with us.
So, I mean, that's quite an history. I mean, 20 years. So that's, you know, a lot of experience in the field, developing also technologies on the way. And now it's actually the best timing for you. So when we go more into the details of distributed power generation, we know that's basically a power generation system that is consisting of several sources, can be smaller scale sources from 1K kilowatt hour until eventually 10,000 kilowatt per hour. It can be also combined, so you can have wind, you can have solar, you can have heat, etc. So that is a super thing. However, there are also several benefits connected to that. So when we talk about distributed power generation and why it's better than having a one bigger source of energy for your company potentially or for your household, we would come definitely to some reductions in terms of transmission losses of energy. Then eventually you have a better reliability on this energy because you have just several sources that are connected. And if one fails, I mean, it's not automatically that the whole chain or the whole combination of sources can fail you in the energy supply. So that is also very important, I believe, in the context of climate change, a little bit connected also to extreme weather events. So potentially that is also something where you can leverage some benefits in that, as far as I believe.
Correct. Yes, absolutely, Anna. It's in terms of decarbonization, solar and wind are great, but they have intermittency issues. So solar, when the sun goes down, no power. Wind, when the wind stops blowing, no wind. Solar is more predictable, as the solar radiation is more predictable. Wind is predictable in terms of long term. You know when the wind's going to blow and when it's not. But when there's no wind, there's no wind. And if you happen to hit that, there's no wind at night and there's no and the solar's at night, you hit these dead spots. Now, as you touched on, Jana, what's really important as well as decarbonization is energy security. Whether we like it or not, our economy is based on energy. Many businesses will say, oh, well, we make these widgets. We're not in the energy business. And then you realize they're consuming gigawatt hours of energy in natural gas and electricity. I think it's important for companies to come to terms with the fact that they are in the energy business. Energy underpins our society, it underpins our civilization. If we lose power, the impacts on our society are dramatic. The impact on business is dramatic. If businesses shut down, keep having to shut down, it impacts the bottom line fundamentally. It impacts their ability to serve their customers and to make money for shareholders and provide jobs for the communities in which they're based. So it's really important for businesses to recognize and to take this first step and say, I am in the energy business. What do I do now?
Mm-hmm. Who could benefit, especially what type of clients in this matter?
So, as with everything engineering, it's frustratingly and notoriously application specific, as you say, Jana. So are you a data center who needs very clean power? Are you a grid firming operator who just needs power and quick response?
Mm-hmm.
So, as you said, with microgrid, you're looking for a blend of solutions. So we would put one of our earliest microgrid projects was done with Sierra Nevada Brewery in Nevada,
mm-hmm.
in the United States, where they've got about 2 megawatts of microturbines generating power and steam.
Mm-hmm.
They've got, I think, a megawatt of battery, and they've got solar. And so they combine all of these to give them the highest level of power security and the lowest possible carbon footprint based on the realities of the market. So the cost
mm-hmm.
and intermittency. So they were very concerned to make sure that they could make beer. Their business is making beer and selling beer to their customers and selling beer of a consistent quality, flavor, taste, etc., which doesn't then suffer from interruptions in the availability of thermal energy and electrical energy. Because most, even buildings they won't just have heat, they'll have electrical. So pumps, stirrers, mixers, you name it, anything that is electrical. If you lose electrical power and you've only got thermal energy, doesn't help, because you still need the electrical power to move stuff and to chill stuff. So chilling is a big aspect of, for example, food and beverage, brewing and things. If you heat something up, on the whole, you have to cool it back down again. And chilling is very important. Also, cold storage, whilst they can withstand, you can close the doors on them and they can keep their temperature a few days. Well, if you need the goods out, that's no good, fundamentally. With the people requiring very kind of just-in-time systems and very tight deliveries, going to your customer and saying, well, I've had to close the doors on my chilled storage because that's the only way I can stop wastage of goods. The customer won't care. They'll say, that's your problem, not mine. Give me my ice cream, give me my chilled this, give me my dairy, give me this, give me that. It will not ultimately, whilst the retailers will say, and customers will say, yes, we're interested in low carbon. Ultimately, if you can't supply them with goods to sell, they will not be happy.
Absolutely, absolutely. What I can imagine is also some important infrastructure buildings like hospitals, etc., could also benefit hugely from your approach, are eventually already in the world, because you already clients serving this.
Oh, absolutely. So hospitals again are an oddity, because they've got a what you call a critical bus application, which tends to be intensive care, high dependency, and operating theatres. They cannot see interrupted power. So again, when it comes to microturbines, they also have a lot of very sensitive equipment that doesn't take kindly to dirty power. So variations in voltage and frequency and power surges. They've also got ventilation systems that need to be powered, the operating theatres. So hospitals again, and also they have a heat load. Sick people on the whole don't need cooling down, they need to be kept warm. So fundamentally they have a high thermal load, they have a critical power load, but they also still need to decarbonize. They still have that need to cut their environmental impact.
Mhm.
So microgrids with batteries, with the microturbine can still work for a hospital.
Mhm.
It's just the criticality is the operating theatres, the high dependency, and the intensive care. There must be power available for those guys as and when they need it.
So, mhm.
And ultimately, in those applications, it's not the facilities manager who decide, it's the clinicians. So if you're selling a power system for a hospital, the clinicians will want to know what impact it has on what they do. Because if they're a clinician, if you're a surgeon or an intensivist, it plays havoc with your medical negligence insurance if people die on your operating table or in your care. So they are very, very concerned. They will be very concerned. And so again, Capstan scores well there, high uptime. We've got about over a 99% uptime. So we're far higher than anybody else. We've got a very flexible, we can follow electrical loads with the micro turbine, with the batteries, of course, the batteries. We can charge batteries, so the battery can deliver the power and we charge the battery. We can do it. This is the thing with microgrids and the use of distributed power generation, particularly for commercial and industrial. So multi-occupancy buildings, hotels, and things. It's about, let's say if you're a 5-star hotel, even if the grid goes out, your customers who are paying 750 euros a night will not take kindly to the excuse that, oh, well, the local grid's gone out. With many buildings, as you know, across Europe, they're not particularly suited well because of the roof design, solar power. It's just, they're old buildings. They're not modern buildings. So putting in some kind of battery storage, perhaps some kind of, and the micro turbine for the heat and the power can really make sure that their customers have the true high-end experience.
I see.
So you've got another example. For example, as vehicles electrify, the way business works, it tends to be that the high end electrifies first. So you've got people who stay in like the Four Seasons, where I was staying in Prague last night. I wasn't staying in the Four Seasons, unfortunately. I wish I was, but they're more likely to drive a Porsche electric vehicle, a Tesla electric vehicle, a Mercedes electric vehicle, a BMW electric vehicle. They're going to be people who are prepared to make the money, pay money, but will have a high expectation. So if they have to leave the following morning and there was a power outage overnight and their car's not charged, they won't be pleased at all with this circumstance. They will expect that everything has happened seamlessly, no matter what's going on in the outside world. So in terms of your kind of on the resorts, the luxury resorts, where people are paying premium prices for premium service, it's very important to recognize that what that means in terms of how you decarbonize and the limiting factors that places on what you can actually do. So for example, if you were in Berlin, for example, which is a city which is very restricted in terms of the power grid. I used to think that London was bad. Berlin is shocking. So fundamentally, luxury hotels, and there are a lot in Berlin, may well have to opt for not just cogeneration, but just flexible on-site power generation, regardless of whether the heat's used or not. And again, the Capstan is very good at that as a distributed power source, because we will match load, and we will match load almost instantaneously. We will behave as the power grid. So effectively, we've got in Chile, for example, in the Chilean mountains, in a 5-star luxury ski resort where there's no hope of getting power, they trust Capstan to run. We are their power grid. We provide them with power and heat 24/7.
I mean, what do they source their power from? I mean,
They
what's
so
the
they
combination?
use so for that one they lose liquefied petroleum gas,
Mhm.
which depending on when you are in the world, of course, because people think decarbonization, they think, oh well, it's this, it's that, but even in the UK, which has one of the highest levels of renewables penetration, where I live in Nottingham, there is still a coal-fired power station running. Where I am at the moment in the Czech Republic, still coal-fired power. And the interesting thing, of course, like the Czech market is that ČEZ, the biggest power generator in the country that runs the biggest coal-fired power station, they've just announced a couple of months ago that they're closing that.
Mhm, mhm.
So for businesses, it's about looking forward as well and saying, where will my power come from? So there is a habit in some businesses of looking 3 months to 3 months. This has inherent risk because fundamentally, let's say this, I've forgotten the name of the plant here in the Czech, when that closes, what will those businesses do? They will, number one, they're likely to see the power price going very volatile, as we see in the UK. In the UK next year, the price of electricity for commercial and industrial users is going to be true free market. They could fundamentally end up paying an unlimited amount per megawatt hour.
So, John, if I may interrupt you, what would you advise those businesses which are basically connected to the provider? I think it was Bohemia. Well, I'm not quite sure now 100% with the name of the provider, but what would you advise those businesses what to do right now?
Right now, start engaging. So here today, I'm actually in Ostrava in the Czech Republic.
Oh, cool. That's cool.
Visiting our partner for the Czech Republic, Slovakia and Poland.
Wonderful.
And I would say to people, start engaging either with myself, Capstan Green Energy, or with one of our partners like Ivitas, and start thinking about it now today. Because if they do it when the occurrence happens, when their energy prices start to rise, with what we've seen with COVID and supply chains, here at Capstan, we're quite lucky. Our supply chain is very US centric, so we haven't suffered the problems. But the likelihood is that everybody will be trying to do everything all at once, and it will lead to prices spiking of equipment, simply because of lack of availability, and people will be outbidding each other because their costs will start to run out of control. They may well see blackouts, which will result in very unhappy customers if you're a B2C. And on a B2B, it can still lead to very unhappy B2B customers who are saying, well, the fact that you failed to invest to keep your plant churning out mince pies or Christmas puddings, well, I'm very sorry, that's not my problem. Their customer will say, that's your problem. Why didn't you do about it? You've just been red flagged on the file as an untrustworthy supplier. So start engaging now, today.
How long does it take when you start the process? So you are either approached by a company or by a business owner. What's the process? What does follow? Is there an assessment? Is there, I don't know, an implementation phase of 1 year, 2 years, 3 months? How fast are you to implement potentially a microgrid, a complete full-blown version? And optimally, of course, that you mentioned several very interesting points in the previous part, which was batteries. We will come to that in terms of storage. Super interesting, and also the role of coal and oil for the next 10 years. So I'm really curious about your perspective on that one. But let's maybe talk first about what's the process, and then we can slightly but steadily go into the emissions part. So why especially emissions are important in the value chain with the increasing need for reporting, with the stricter regulation that we are seeing now being implemented more and more. So maybe we can go just step by step because it's a huge topic. So maybe you can tell us more first about the process. So how does Capstone come in? How long does it take? What are the efficiencies that you look at typically with a certain combination, just to prepare the business owners which are in one or of the situations which you mentioned, to start acting accordingly, start planning ahead?
Yeah, so the first point is we can move as fast as you can. So we're interested in people who want to move. So our resources include, we can do, our partners like Ivitas here in the Czech Republic and others can do energy engineering. So very quickly, they can do an assessment of what your needs are very quickly. They can give you advice, usually paid, on how to reduce energy consumption. Then, of course, what we also offer then, because we accept that budgets, capital, demand on capital. If you are a hotel, for example, or you make mince pies, you may want to deploy your capital based on your shareholders saying, who may not be so sympathetic as we are, you and me and others may be, on the fact that you need to get involved in the energy business. They might say, well, why aren't you buying more machines to make more mince pies? Why aren't you investing in improved recipes? So one thing we do here at Capstan is rental, long-term rental. So we're interested, so fundamentally it avoids the CapEx upfront of the major capital components. There is still some CapEx, but it tends to be very small.
What's the difference, if I may jump in? What's the difference? I mean, for example, the investment, if you have a large scale solution compared to when you're going to rent the parts, if I understand it right, and how long can you rent it? I mean, long term is a very generic word. Is it 20 years or 10 years or 5 years, or how are the contracts set up, in what duration?
So on the whole, we prefer to do over 5 years, but we can do up to 20 years. So this is where we say, let's get this deployed. Let's bypass your capital budget procurement. Let's get it in rental. So, but not only that, we can do schemes like rent to buy. So we can say that, for example, if the rental price is right, after 5 years, the equipment turns over to the user. So fundamentally, they then own that equipment. With our rental agreements, we build in maintenance plans. So everything is covered fundamentally, and it's maintained by one of our partners.
Wonderful.
So that's the idea. So we can move as fast as you can as an end user. We could probably, in some cases, move a lot faster, because simply we're interested in getting our capital deployed as well. So we would come in, we do an assessment based on energy. We can do a desktop exercise, or we can do something more advanced. So if it's a simple look at your energy bills, look at your half-hourly metering data on gas and electricity, well, that's something we do free of charge, because it's actually very easy to do. But if it gets more in depth about a full-on energy assessment, then it usually becomes chargeable. But we have a standard tool when we know your half-hourly information. So yeah, and then we'd move that, and then we'd move. Capstans again have this advantage, because we have very low things like nitrous oxide, powerful, not only a powerful greenhouse gas, but also for air pollution and the creation of particulates and other horrible things. We're the lowest in the market by up to 750 times lower than the next best technology. So in terms of our exhaust gases, we're very clean. VOCs, or expressed as methane, for example, we have virtually no methane in the exhaust. Again, methane, very powerful greenhouse gas. We have very low carbon monoxide, and we don't have one of the hidden air pollutants that no one talks about, is formaldehyde. We have no formaldehyde in our exhaust gases. Formaldehydes form through engines, because engines have to burn oil. You can't help it. It's in their design, they burn oil. And that results in the formation of formaldehydes. Now, medical samples, to give you an example, are pickled in formaldehyde. It's that unpleasant to biological existence. So fundamentally, we're very low. And because we don't use lubricants or coolants, I'll mention scope here very quickly here, Jana, because most businesses are waking up to the fact that their scope 3 emissions are their highest emissions, and they are the most difficult to account for, and they are the most difficult to remove.
So maybe, John, if we just take a little step back now,
Yeah.
because we have a very mixed audience of people that are very advanced with actions they are taking towards being carbon neutral,
Yeah.
or decarbonize their supply chain, or people that just hear the topic the first time.
Yeah.
So when we talk about reducing your emissions in your supply chain, can you tell us a little bit more, just from the advising point of view, what type of emissions do we have? Why one or the other is especially important? We know that we have mandatory reporting on, if I'm not mistaken, emissions of the scope 1 and 2, especially emissions number 3, which is a little bit of a further field, especially in the supply chain, because it's all your indirect emissions, if I'm not mistaken, is recommended. So maybe you can tell us a little bit more. Okay, so this is where the reporting is right now with the regulation. These are the emissions which are just falling into these categories. This is what you can mitigate, what you can change, how you can change this, especially because indirect emissions, the word already says it, it's not something that is directly connected to you. So what can you share with us?
So I'll start with the direct briefly, which is which is fundamentally your direct emissions. If you're an individual, it's the emissions from your car that you drive to work. Those will be classified as your direct emissions. So it's what happens that the business provides from its internal operation. So the fact that you're raising heat or means that you're generating emissions. The fact that you have a demand for heat, the fact that you have a demand for electricity is kind of a scope 1. So it's anything that you do in-house. So fundamentally, anything you create in-house. So in cogeneration using fossil fuels creates scope 1 emissions. How big those scope 1 emissions are depends on the efficiency and the design of the equipment that's doing the power generation. So back to Capstone, low nitrous oxide. We don't use things like urea to scrub exhaust gases. We don't use rare earth element catalysts. All these things add to scope 1 emissions. But it gets very complex because they also add to scope 3 as well. The two are very tied together. So we aim to reduce your real scope 2 emissions. It's largely from carbon dioxide reduction, real nitrous oxide reduction, say up to 750 times lower than the alternative. Virtually no methane emissions, which is very important. These would be scope 1. Your scope 1, if you were looking at a business, whether you're multiple occupancy, residential, hotel, leisure facility, leisure complex, or manufacturing, those would be your scope 1. So scope 2 is fundamentally quite low because it's the amount of energy that's used to deliver the gas and electricity down the wire and down the pipe. So on the whole, that's fairly low and it's not problematic. Where it gets really problematic, as you just hinted to, Jana, is scope 3. And how on earth, let's say, for example, Capstone doesn't use lubricants and coolants. So you don't need to worry about that. You don't need to go to your lubrication or coolant or lubricant supplier and ask them how they account for emissions in the creation of these two products. How do they account for the creation of emissions in the manufacture of urea? How do they account for the emissions from the manufacture of rare earth element catalysts? How do they account for the emissions from the spare parts? Again, all major Capstone microturbine components are remanufactured. The circular economy is a buzzword. We've been pretty much circular for 20 years. We remanufacture all our components, all our major metallic components, which have heavy carbon, we remanufacture.
Okay.
And it's possible for those to last up to 20 years. So very, very long carbon cycle with the reuse of components. So this is where your scope 3 comes in, because those metallic components, if they go to waste and then, oh, I'm sending them to the waste. Yeah, they're recycled. How are they recycled? Tell me what's the energy used to recycle them? How many trucks do they travel in? What's this? Where are they going? And the complexity of scope 3 is such that it's easier just simply not to have them. I had a conversation with the global sustainability manager at Diageo, a very big brewer and distiller. And they discovered, she said, that we thought we were doing very well until we realized our scope 3 emissions are 90% of our emissions. So it's fertilizer for the barley and the hops, it's bottles, it's cans. They were shocked, and they said, well, this is where they're focusing their effort. Because they're using the bottles and cans fundamentally, and they're using the barley and hops, their emissions footprint, they said they were very surprised. So you'll see, if you follow PepsiCo at all on LinkedIn or Mars or any of the very big consumer goods manufacturing, you'll find their focus seems counterintuitive, but they'll be talking about agriculture. And we'd say, we don't want to add complexity to your life. If you're having to scratch your head and think, right, okay, how do I account for these scope 3 emissions? And it may even work for smaller suppliers who nominally, oh, that doesn't apply to us, we're too small. What happens when your customer knocks on the door and says, tell me about your scope 3 emissions? That's a commercial relationship. That's not regulatory. And customers, if you look at Diageo, for example, as the question, they're already asking those questions of their suppliers. They want to know. And that's nothing to do with regulation per se. That's to do with the commercial relationship. So people who think they can get away with it simply because they fall outside the regulatory framework need to be thinking about what their customers think, what matters to their customers. So, for example, here in the UK, Tesco's are having a huge drive. They used to put cogeneration plants in. Of course, they've got enormous metal sheds, fundamentally, like most supermarkets. And they're covering the roof with solar. They're putting in batteries. They're upgrading grid connections. They're getting ready for their fleets of electric delivery vehicles. They may have also eventually revert to cogeneration, because they may, of course, find that there just isn't enough power, particularly when they electrify their delivery fleets and their trucks. They may find that they have to revert to some form of fossil. But Tesco's is probing into its supply chain because it recognizes scope 3 emissions sits in its supply chain. You may be a small supplier to Tesco's, and you may fall outside the regulatory framework for having to declare those emissions. Tesco may want you to declare them on their behalf, because they may say, well, actually, this is part of our commercial business risk. In our supply chain, for example, carbon pricing, it's a reality. It's spiking here in Europe very heavily. They might say, how are we managing our future supply chain risk? So, for example, if you are manufacturing pies for them, they might say, well, that's got meat in it, it's got sugar, it's got salt, it's got fats, it's got this and that. What's the risk to Tesco's of there being a price rise which they can't pass on to their customers in a manageable fashion? Same with a hotel, same with anybody that sells anything to anybody that has an energy content, which means it has a carbon content and emissions content. Don't wait for the regulator to tell you what to do. Start worrying about what your customers may want you to do, and knowing what some of their customers are like. With the big retailers, they might just come in and say, if you want to do business with us, you have to declare these emissions, because it matters to us, it matters to our customers. And so it may well be that if you're not ready for them, they may well give you a black mark as a supplier and say, well, guys, this is kind of obvious. Why weren't you doing this? Haven't you been reading our annual reports? Haven't you been looking at what we've been saying? Why weren't you ready for us? So I think, yeah, in terms of a risk point of view, there's two aspects: cost of energy, which is rising precipitously,
Yeah.
and risk from the supply chain of asking suppliers questions they can't answer, and then having to do it in a hurry, and then having to do it in a very, very expensive manner, because things that need done at the last minute are often very expensive because you run out of time effectively. So yes, scope 3 and scope 1, be very aware of what those are and how people like Ivitas, Capstone Green Energy, and our other suppliers can help you with that to minimize that exposure so you're ready. Or you can even go to your customers and say, this is what we're doing, and shout about it. We make sure that you will, if you're staying in the Four Seasons Hotel, for example, even if the whole Prague grid blacks out, you will still have all the facilities you paid for at your disposal. You will still be able to do everything we promised you. For example, that's a selling point fundamentally. But it's the same with let's say with a retailer, that the strong, I'm not sure that what it's like over the rest of Europe, but many retailers, they probably won't pay you more money, but it will make, because that your business and you are paying attention to things that matter to them as businesses, they will probably look on you favorably, and you will be a first choice rather than, oh well, you know what, these guys have come to us and said, we want to do this with you, we're interested in what you're doing, we're interested in how we can help you. It may not have a financial incentive, but it may have a long-term relationship incentive.
I definitely agree with you, John. Sorry to jump in, just to interrupt you.
Yeah.
Definitely, it's also a reputational risk and the possibility or opportunity to position yourself. What is the risk and the potential for a business having a microgrid installed, established for their business? And what you see in terms of future, what's the role of coal going to be in the short-term horizon, talking about 5 to 10 years, according to what you see right now?
So for us, we see coal's going to be around for a while, along with over fossil fuels. Just briefly, I thought I'd cover it off. We think, looking at the reality on the ground, so say here in CEZ in the Czech Republic, it shuts its coal-fired power station. The Czech Republic doesn't have high solar radiation, and it's not very windy. Where do you go? You go to natural gas. So, but there's a lot of coal in the world. So switching to natural gas cogeneration, where the grid is in part or wholly coal, you can't help but reduce your carbon emissions. And that would include off-grid LPG, liquefied petroleum gas, as well as liquefied natural gas, as well as gas mains. You will reduce your emissions. You can't help it effectively.
So what's, I mean, that would be a little bit of, but we ultimately aim for switching off the dependency to fossil fuels. I mean, everybody's talking about that. We all want to do it. We know it. The regulation is being put in place to go to actually start the path already. And now you're going to tell us, no, we need to still go back to natural gas and oil and this type of stuff. So what is it, a medium-term solution? Then comes the next step, or how is the technology developing? What's the path on which we are? How do we get to the truly decarbonized ecosystem to generate energy?
So, as Bill Gates says, at the moment, it's about slowing the fill rate of the bath of carbon. So what you can reduce today is good. Now, in the industrial and commercial market space, heat pumps are available, and they're a very good way of decarbonizing heat. But for example, where people are seeing electricity prices of 22 pence a kilowatt hour, even with the most efficient heat pump, if you went to your financial director, financial controller, and said, we'd like to do this, and this is going to be the power bill, you'd be sent away and told to think again, effectively. So one of the things that Capstone does is that and this is where microgrids become very, very strong, is that we put microturbine, fossil fuel, with heat pump, with solar, with battery, So what we're looking to do is to say, right, okay, so when the sun goes down, there's going to be no electricity from your solar. Long duration battery storage is not here yet. It's great for peak lopping, it's great for peak shaving and other things like that, where you're seeing it being sold into some spectacularly large schemes. But fundamentally, so what we say is heat is the one thing that all of industry, commercial and industrial, is struggling to decarbonize. The technology is there, the heat pump, fundamentally, but it's too expensive. Operating costs are through the roof. So fundamentally, Capstan, again, it becomes, you need someone like Ivitas or Capstan or one of our suppliers, becomes about a thermal system integration. So we, based on kind of examples, we can cut by integrating a Capstan with a heat pump just alone for heat raising, we can cut carbon emissions by up to 70% today, here, now.
So just to put it into perspective, implementing a capstone micro turbine just to increase the efficiency, etc. If I got you right.
With a heat pump.
With a heat pump.
You can cut your carbon emissions here, now, today, 70%, up to 70%. So we see in industry a lot of dithering. Oh, well, we need to wait for heat pumps. No, what Bill Gates, we've got to slow the fill rate of the bath now, today. And the interesting thing about that configuration is that fundamentally the payback on that, the commercial payback on such a system is between 3 to 4 years. So actually, for many people, it's viable today, here, now, to cut their carbon emissions from thermal energy. So for heat raising, whether it's buildings, whether it's manufacturing, they can cut it today. So they can take a big chunk out of it. The beauty of the system as well is that it's hydrogen biomethane ready. So we can, if hydrogen ever becomes available, that's probably a good 15 to 20 years away in terms of commercial viability. The kit's future proof. Now, again, we can integrate solar with that because fundamentally it's all electrical power. So we can have, for example, we can install a bigger capstan than we need for thermal energy, for example. But the idea of that is that at night, when the solar's out, the capstans spool up to provide additional electricity. The battery provides the short duration storage, for example, if you're going to rely on the power grid, for example, if you have to rely on the power grid. Because one of the things that's very clear in the UK is that there's no, what they call, people will know as time and duration of use charges for the network. Those are gone. That's been added onto the half-hourly bill. The market rate floats free. So fundamentally, having a battery on a microgrid with solar, you can isolate yourself from the power grid when the power price goes
through the roof, which it already did.
When it goes thousands or potentially tens of thousands per megawatt hour, you come off the grid automatically and you can island mode. And so this is the beauty of microgrids, is that ability to be more self-sufficient in power, not so dependent on power grids. Because of the way democracies are structured, the politicians will always flick the breaker on industry first. They will never try and flick, they will do anything they can to avoid flicking the power breaker on consumer load, but they will happily do it to industry. So again, another thing for listeners and watchers to think about, again, it's not about the law, whilst it is, it's about your customers, but it's about what the politicians will do. If there's a power crisis, who will they protect? Well, I'm very fortunately, as a company, you don't vote, you're out effectively. So it's about not only about energy efficiency, it's not only about decarbonization, it is about energy security. So it may mean, for example, investing in a low carbon fossil fuel asset like a microturbine that you will only ever run on for power, but you have it there because you may well need to run on your own power for an extended period, for example. So there was a blackout in the UK. We had a gas-fired power station go down, and a wind farm got hit by lightning. And there was a huge blackout. And of course, the consumer loads were bought on first. They will always be bought on first, which means that you can be down for hours. Well, if you have a system that can react instantaneously and you just carry on running, and you're carrying on delivering for your customers, you've not got wastage and all those other things. If you're a manufacturer, or if you're a resort operator, a leisure club operator, a hotel operator, your guests don't know. Basically, all they know is that they've gone round and they've used the spa.
Until you tell them, exactly. So it's also a little bit, I mean, you mentioned the point before, telling what you do to provide basically the service that you are selling or providing.
Yeah, so this is microgrids. Microgrids are about power security, they're about carbon reduction, and they're about energy efficiency. And the fact that you may have an asset that you will never run, if you're worried about power security, well, that's going to be a cost of doing business because of the politics of power.
Interesting point that you make in the end. So, John, would there be any other points just to conclude with your words?
I think, yeah, I would reiterate the point. Start acting now. Don't wait until it strikes you in the quarter that it strikes you, because then it's too late and you're going to be with everybody else. There's already a shortage of skilled labor and people with expertise. It's become very clear. You speak to anybody who's trying to recruit people who can do operatives, who can do installation works on site. There just aren't people out there at the moment to do the work. So don't end up at the back of the queue or paying 100% premium on price. Do it now. Think long-term into the future, but not necessarily long-term. I would say short to medium term as well. And think about ways like with Capstone, you can do it so you don't have to eat your own capital budget. We're very keen to stop you doing that, so we can do those kind of things. And we've also got, we can set up special purpose vehicle companies which have a long-term contract with you to supply energy. So if you don't want to rent and you just want to buy power, we have options where there's a specific company set up. One of your directors can be on the board of it, and fundamentally it's there, and its only reason for existence is to provide you with secure, reliable, low carbon power. So there's many ways we can do it, but act now.
Don't
is
wait.
my message.
There is no time to wait.
No, it's for some people, as you correctly pointed out, Jana, for some people it's already happened. And they may think, oh, well, that was an anomaly. I can tell you from the UK experience, as renewables gain penetration, it gets worse and worse and worse.
Now you refer to the price or
yes, record prices of electricity.
Yes.
So we were looking at a minerals dryer in the UK, and historically LPG has been a very poor fuel for cogeneration. The spark spread, which is, as you know, for your viewers and listeners, is the difference between the cost of the gas and the cost of the electricity. The spark spread fueling on LPG is 15 pence. It's getting wild, is what I would say. And again, there's no guarantee that if there's a difficulty over the winter, we haven't yet. The UK gets cold January, February, March, not this side of Christmas. So there's no reason why that power price won't go higher. But that 15 pence spark spread is the base electricity price, 22 pence a kilowatt, base electricity price, no longer 9 pence, 12 pence, 14 pence, 22 pence, they're paying base electricity. Everything else for spiking will go on top of that. So, yeah.
What I'm just thinking about is also in terms of cogeneration. So there are also possibilities to combine the heat production basically coming out of waste treatment procedures, either from wastewater or waste incineration. So that would be eventually a kind of combination that we could also look at. I mean, eventually we will not manage it in this call today, but maybe we can have a follow-up session and also see what the feedback is after the call and deep dive on that part as well. But I could see that would be also a even more lower carbon combination that would just, push us step by step into the direction just to mitigate as much as possible.
Yeah, so I'll cover that very quickly. We can help with that. We do modular scalable anaerobic digestion. Now, how this works, as you're probably aware, next year, EU legislation, which includes the UK, was enacted before the UK left. There's going to be a requirement to source segregate food waste from general waste. And of course, the waste management companies, which are fundamentally road haulage companies, are eyeing up the money they're going to charge businesses and consumers for hauling away food waste and sending it to anaerobic digestion plants. They will want to charge you mileage haulage fees or want to charge you gate fees. We're here to say, well, actually, no, don't throw it away. It's a resource. This is your resource. You are the company. It's your resource. And we can basically generate biogas off that to help you offset carbon to be used in the turbines to generate power and heat.
Exactly.
But it also then...
You're back, John. We see you.
...to disposal. Fundamentally is to use it as part of your carbon reduction program in your energy savings program. But then also you've got something which is a valuable fertilizer, effectively, that you can either sell or you can gain a relationship with a local farmer or however, because with carbon pricing, nitrogen fertilizer is going up in price and it will only get more and more expensive. So these organic materials, which will be converted into what is a liquid fertilizer, will be valuable for people growing crops. They could be valuable even for amateur gardeners, allotment holders, and things like that to put on their soil for fertilizer. And it would be a very, again, a circular economy. The idea of this product is cost reduction,
emission,
carbon reduction,
absolutely,
circular economy.
Absolutely.
So fundamentally, the stuff goes back on the ground and back around the loop it comes.
Exactly.
So we're very interested. We can have another call about that, Jana, for your viewers and listeners.
Would be wonderful, John. Many thanks for sharing with us all the insights and the perspective. I mean, we tackled quite some points in what we had on the list. So many thanks for your time, John. Don't want to hold you back on your visit in Czech Republic. Best of luck. Just
Thank you.
Maybe for the listeners and the viewers, if you have any comments regarding the session, you missed some points, or there would be something especially of interest for you that we can potentially cover in another session with John Buckhock from Capstone, let us know. You can do this in the comments section. When the video is published, you will definitely see more details on our LinkedIn page, LinkedIn profile first, and then on all the other channels. So there will be a series of calls. This is one of the opportunities to talk to industry experts, people extremely knowledgeable, extremely competent in the area where they are working or active in. So we will continue with this also in the year 2022. And please bear with us. I'm going to share a list with you with the lineup of people and speakers and topics that we're going to cover in the following weeks and months. So thanks a lot for being here with us. Thank you again, John, for being with us, sharing with us all your expertise or your insights, representing Capstone, and good luck with everything. Have a great and relaxed holiday season. If you celebrate holidays, and absolutely an amazing start into the next year.
Yeah. And thank you for having us on to speak, Jana. It's greatly appreciated. And we hope what we've said will help your listeners and viewers navigate what is a very difficult subject in a very difficult time.
Absolutely agree with you. Let's close the call with this words. I wish you a very good rest of the day. Talk to you soon, and bye-bye.
Bye.
Bye-bye.